For this code example, we will create an animal class at first. We will then create a mammal class and a bird class, and the mammal and the bird classes will inherit from the animal class. And so we'll start building this tree, and we'll create even more subclasses from the mammal and bird classes. So let's start. At first, we create the animal class. We will keep things simple. So we will have just one attribute named animal name. Next, let's create the constructor, and let's create a simple method, the getName method. Now, if we think logically, then no matter what kind of animal we create, they must have a couple of abilities. For example, they must be able to eat. At the same time, they must be able to breed. These two methods should be there no matter what kind of animal we create. So these two methods should be defined in the animal class. However, different animals eat differently. At the same time, different animals breathe differently. For example, mammals might use their lungs to breathe. However, fish use their gills to breathe. In a similar way, a dog might eat its food by chewing, but a bird usually pecks and swallows its food. So the concept here is that even though every animal needs to eat and breathe, how they eat and how they breathe may differ from animal to animal. And this is where we can use abstract methods. We can create an abstract method for eat, and we can create an abstract method for breathe. However, these abstract methods need to be created in the animal class, because every animal eats and breathes. The implementation code of these methods will be written in the subclasses that inherit from animal. This will become a bit clearer when we go through the example. So let's continue. Let's create an abstract method for eat and an abstract method for breathe. So here, this is the access modifier. This is our abstract keyword, signifying that this method is an abstract method. This is the return type, and let's say we don't want anything to be returned. We will just print something out, and this is the name of the method. The same happens with the breathe method, but you can see that this is giving us an error. That is because any class that has an abstract method or multiple abstract methods, the class itself must be defined as abstract. So here we have to use the abstract keyword, and our error is gone. For now, let's say our animal class is complete, but keep in mind that our animal class is not concrete, because this is an abstract class and we cannot create objects from our animal class. So let's start to think about subclasses. A mammal class might inherit from the animal class. We might also have a bird class that can inherit from the animal class. So let's create those two classes. At first, we will create the mammal class. The mammal class will inherit from the animal class. So we type extends animal. The moment we write extends animal, it greets us with an error, and that says that the mammal class must be declared abstract, or it has to implement the abstract methods from the animal class. We will eventually do that, but at first let's define some attributes for our mammal class. The first attribute we can think of for mammals is, let's say, the number of teeth. Teeth count is a good attribute because generally all mammals have teeth, apart from a very few exceptions. But anyway, let's move forward. Let's create the constructor. Because mammal extends animal, we use the animal constructor by using the keyword super. We have discussed this in detail in the chapter where we covered inheritance. Great. Now let's create a couple of methods. The getName method is already there for animal, so we do not need that for mammals. But let's create the getTeethCount method. You can create a setter method here as well, but just keeping things simple, we are not going to do that right now. Now let's create the eat and the breathe methods for mammals. Since the eat and the breathe methods were abstract methods in animal, and mammal is a subclass of animal, we must override the eat and the breathe methods. Let's first create the eat method. We write override at first, then comes the method signature, and we can just print something out. We do the same thing for breathe. Since we have overridden both the abstract methods, the mammal class is now concrete, and we can create objects from the mammal class. So at first we created an animal class, and then we created a mammal class, and the mammal class inherits from the animal class. The animal class has a few methods. The first method is getName. It also has an abstract method named eat, as well as an abstract method named breathe. The mammal has the getTeethCount method, and of course it overrides eat and breathe. Let's represent overridden methods in green. Now let's create another class named bird, and it also inherits from animal. So we will create another class named bird, and we will make it inherit from animal. An attribute for a bird can be its wingspan. We can now create a constructor. Again, we're just keeping things simple, and we have the constructor of its parent class, and we are setting its wingspan attribute using the constructor. We have a getWingspan method, and since bird extends animal, bird also needs to override the eat and the breathe methods. Great, now we have overridden the eat and the breathe methods in the bird class as well. So going back to the diagram, the bird class has a getWingspan method, and it also has the eat and the breathe method that it overrode from the animal class. Keep in mind that both the mammal class and the bird class has the getName method, because when you inherit from a parent class, you also inherit their methods in addition to their attributes. And now both mammal and bird are concrete classes, which means that we can create objects from these classes. We cannot create objects directly from the animal class because animal is an abstract class. So in the main method, we can create mammal and bird objects. Both of these objects will be able to call the eat method and the breathe method. So let's call the eat method for both of them, and let's run the program. And the results are exactly what we expected them to be. We can think of the abstract animal class as a blueprint for the classes that inherit from it. What the abstract animal class is doing is defining a few essential things that each and every animal must have in the form of abstract methods. So more concretely, each animal must eat, each animal must breathe. How they eat and how they breathe is dependent on the animal, but they must eat and they must breathe. So you can think of the animal class as something that is dictating what abilities other animals must have. Each animal must be able to eat, each animal must be able to breathe. How they eat and how they breathe are dependent on how each individual animal implements it, which is why the abstract class only has the method signatures. It only dictates that if you inherit from me, you must implement these methods. And since bird inherits from animal, it has to override the eat and the breathe methods, and it overrides it and implements these methods in its own way. The same is true for mammal. Mammal inherits from animal, but mammal implements its own way of eating and its own way of breathing. And so we can think of abstract classes as partial blueprints of their subclasses. It ensures that if this class is in the inheritance chain, some class in that chain must implement these methods. So I hope that is clear. Let's create one more layer. Let's create a few birds and also a few mammals. Let's say we create a lion class that inherits from mammal, and we also create a zebra class that inherits from mammal as well. And before we think about our bird classes that we want to create, let's think of a common ability of birds, which is to fly. Now, different birds fly different ways, and some birds cannot fly. So each bird should be able to implement its own fly method. But from a design perspective, we can make the bird class dictate that each bird that inherits from the bird class must implement some form of a fly method. So we can keep that fly method abstract, and we can keep that in the bird class. So whoever inherits from bird must implement its own fly method. There cannot be a subclass that inherits from the bird class and does not implement fly. Each subclass that inherits from bird class now must implement fly, because we have created the fly method as an abstract method in the bird class. So we can create a penguin class and a sparrow class maybe. And because they're both birds, they inherit from the bird class and they must implement their own fly method. Now, because bird has an abstract method, bird itself has to be an abstract class, and bird is not a concrete class anymore. So we cannot create objects directly from the bird class. So let's create these 4 classes in our code. We'll have a lion class. We will also have a zebra class, a penguin class, and a sparrow class. Now, if we go to the lion class, we need to extend mammal. We can have an attribute, let's say color, and then we can go directly to the constructor, and then we can have a method for the lion class. Now we have the method for lion. Let's move on to zebra, which extends mammal as well. We can have any attribute. For example, we can have type. We have this constructor, and then we can have its own method for zebra. Let's move on to the more interesting class for this example. Let's move on to the classes that inherit from the bird class. So a penguin will extend bird. Again, we can have any attribute, and these are just examples, so don't really matter much. We then build the constructor, and as always, its own method. As explained in the diagram, we want to implement an abstract method in the bird class. So let's do that first. This is the bird class, and we can have an abstract method here. We'll use the abstract keyword, and that's it. We have the method signature for our abstract method fly in the bird class. Of course, since now bird class has an abstract method, the bird class itself needs to be abstract. Great. Now going back to our penguin class, here we must implement the abstract method fly because penguin extends bird. So we override it, and that completes our penguin class. Now moving on to the sparrow class, this is an example attribute. Now let's move on to the constructor. Sparrow extends bird, and this is the constructor. It can have its own method, and since it extends bird, it also needs to implement the fly method. So it'll override the fly method. And so now all our classes are complete. Our bird class is an abstract class. Our animal class is also an abstract class. All the other classes are concrete classes. So we cannot create objects from the animal or the bird class, but we can create objects from all the other classes that we've created. So moving back to the diagram, what it essentially looks like is this, right? And if we write out the methods of the different classes, they will look like this. And from here, we can create penguin objects, sparrow objects, zebra objects, and lion objects. So we have designed our class structure in a way where, let's say, in the penguin class, we did not have to do a lot. We only had to implement the analysis and the fly method. Everything else came from the classes that it inherited from. Because animal had 2 abstract classes, lion, zebra, penguin, sparrow, all of them have eat and breed methods. In the same way, any bird will have the fly method because the bird class had an abstract fly method, and anyone who inherits from the bird class must implement the fly method themselves. And you can keep on going like this. You can keep on creating different types of lions and different types of zebras, different penguins and different sparrows. Or we can just stop here, and this can be our last layer, and from there we can create as many objects as we need. So if we take any one of these examples, for example penguin, getName comes all the way up from animal. Any penguin object will have access to the getName method because penguin inherits from bird and bird inherits from animal. And so bird inherits the getName method from animal, and penguin inherits the getName method from bird. And so any penguin object will have the getName method. In the same way, any penguin object will also have the getWingspan method because the getWingspan method is a method of the bird class, and penguin inherits from the bird class. When penguin inherits from the bird class, it inherits all of its methods as well. So penguin will have getWingspan, eat, and breed. Now, it also inherits the abstract fly method because the method is not defined in the bird class, or the implementation of the fly method is not there in the bird class, and penguin inherits from the bird class, it must define its own implementation of fly. One more very important concept is that just because bird inherited from animal and animal has 2 abstract classes, it does not mean that bird has to implement both of those abstract classes. It can choose to override the eat and the breed method, but it can also choose to not override any of these 2 methods. So for example, if bird only overrode the eat method, but let's say it did not override the breed method, then what would happen? Let's look at the code. So let's go to the bird class and comment this out. So now we have commented out the breathe method, which means that bird does not override the breathe method. So now we'll see that we'll actually get an error in the penguin and the sparrow classes. Why? Because now penguin needs to implement the breathe method, as you can see in this error message. So here we'll have to override the breathe method like this, and now our error is gone. The same thing will happen to sparrow. It'll also show us an error, and we need to implement the breathe method here as well. So going back to the diagram, what essentially happened is that bird did not have breathe method. So now penguin overrides the breathe method. And if you are to create even more classes out of birds, like different other birds, they will also need to implement the breathe methods. Of course, that is not good design, because more or less all birds breathe the same way. Since all birds more or less breathe the same way, this should not be implemented in each bird class separately. This should be implemented in the bird class only once. And so we will revert back to what we had before. But the reason I showed you that, the reason I had it this way in this example right now, is to explain that the class that directly inherits from an abstract class does not need to define all the abstract methods of that class. But if it chooses not to define one of the methods or any of the methods of the abstract parent class, then that method has to be implemented by some subclass, either here or even lower in the chain. It doesn't matter. What matters is that at some point, these two methods have to be defined by some child. Which child in the vertical hierarchy does it doesn't matter. So if animal has two abstract methods, eat and breathe, and if bird implements only the eat method, it overrides only the abstract eat method and does not override the breathe method, then some other child of bird must implement the breathe method. At the end of the chain, this chain is animal, bird, sparrow. This is one chain. Animal, bird, penguin is another chain. If you think of chains, then someone in the chain has to implement the abstract methods. And at the end, when you have a concrete class, that class has to have all the methods defined of its previous parents. And that is why sparrow had to define fly, and it had also the responsibility to define breathe, because bird did not define breathe here. But as I said, that is not good design. All birds breathe more or less the same way. So we will keep it as we had it before. And we will also change the code back to its original state. So in our design of this class hierarchy, this was an abstract class, and this also was an abstract class. All the other classes are concrete classes and can be used to create objects. So let's create a couple of objects and look at the output that we get. Let's create one from the mammal tree and one from the bird tree. So let's create a lion object as well as a penguin object. And let's test out their methods and let's see what the output is. So when the lion eats, that's what it says, which is in accordance to how we programmed it. This is a penguin, so when it eats, it actually pecks. When asked to fly, a penguin cannot fly, so that's what we put in the fly method for a penguin. And the different unique methods of the lion and the penguin are here as well. So I hope now you understand how abstract classes work and how abstract methods work as well.